Hey everyone. So yesterday in the Desmos, somebody asked me if I would do workout solutions of all of the problems I've given you guys over the last few days. So that is what these videos are for. I'm going to crank out all these problems I gave you. It's going to be a grand old time. I'm going to have like 20 problems to do, but hey, that's okay. All right, so these videos again are just me working out the solutions. There's no new math or anything like that in there. All right. So the first one for day 2 I gave you was cosine squared plus tangent squared times cosine squared. And remember, one of our strategies was that the GCF, the greatest common factor. So if I look at both pieces of this, I do in fact have a GCF that I can take out. I have a cosine squared that I can factor out of there. So I'm going to go ahead and take that out. So if I take a cosine squared away from a cosine squared, I'm left with a 1. You can kind of think of it as, well, what happens if I take a GCF out of this? What's left? My GCF would be an x, and if I took an x away, I would have 1 plus 5 left. So it helps to think of terms of x's do that. And again, we know if I distribute this back in, I should end up with what we started with. All right. Next thing that's jumping out at me is this piece right here. So I see a tangent squared, so that immediately makes me think of the Pythagorean identities. So we have 1 plus tangent squared right here. And it looks like another way we could write 1 plus tangent squared is as secant squared. So I'm going to replace this whole bit right here with secant squared. There's no identities where we're multiplying things together. But one thing I could do is rewrite secant squared in terms of sines and cosines. So I know another way I can write secant is as 1 over cosine. And because this is secant squared, this would actually be 1 over cosine squared. And now since I'm multiplying these things together, I know I can cross things off. So since I have a cosine squared on bottom and a cosine squared on top, those can cancel out. And all I am left with is a 1 over 1, which is just 1. So your final answer for this is just 1. All right, let's do another one. So we have cotangent minus cosecant squared times cotangent. Again, first thing I'm going to look for is that idea of a GCF. And if we notice, both pieces of this has a cotangent. So I'm going to go ahead and factor out a cotangent. So when I do that, I'm going to be left with a 1 minus cosecant squared. And again, I see that squared in there, so that immediately makes me think of the identities. So the Pythagorean identity that I have that deals with cosecant squared looks like this. So here's kind of one of my side notes. And I want to manipulate this identity so that it looks like 1 minus cosecant squared. So it looks like in order to do that, I'm going to have to subtract cosecant squared from both sides. So I got the 1 minus cosecant squared here, and then in order to get that totally by itself, I'm going to have to subtract cotangent squared from both sides. So it looks like 1 minus cosecant squared is really negative. That negative is important. Negative cotangent squared. So I'm going to replace this whole piece with negative cotangent squared. And now if you want to think of it in terms of the x we could write this as x, and this would be negative x squared. X times negative x squared is a negative x cubed. So cotangent times negative cotangent squared would be a negative cotangent cubed. All right, moving right along here. All right, so the next one was secant squared minus tangent squared plus cotangent squared. Let's see. There's no GCF that I can take out from all of them. So I gotta scratch that idea. I think I might do this one two ways. We'll see. The first thing I see is secants and tangents together. And I know there's an identity with secants and tangents that are together. So here's again my side note. And I want to get this. Hold on, I think a second. Yeah, that'll work. I want to get this so it's secant squared minus tangent squared. So I'm going to subtract tangent squared from both sides. So now I have that secant squared minus tangent squared by itself. And it looks like secant squared minus tangent squared. Another way I can write that is just 1. And that plus cotangent squared is going to carry down. And now I see cotangent squared, and again, I know that's another identity. So it looks like, again, a side note, it looks like cotangent squared plus 1 equals cosecant squared. And hey, look at that. That's actually exactly what I have. Cotangent squared plus 1 is cosecant squared. So this whole expression equals cosecant squared. All right, here's our next one. So we have tangent squared times cosine squared plus cotangent squared times sine squared. Let's see, if we think of order of operations, order of operations says we do multiplication first. So I think I'm going to clean up these pieces right off the bat. And I think in order to do that, I'm going to change things into terms of sines and cosines. So I know another way I can write tangent is as sine over cosine. So this is going to become sine squared over cosine squared times cosine squared. And then plus, same thing over here. So another way I can write cotangent squared in terms of sines and cosines is as cosine squared over sine squared. And then again, times that sine squared. So let's see if I clean these up. Again, there's all multiplication in there, so I can cross things that are off on top and bottom. So since I have a cosine squared on bottom and one on top, I can cross those off. And it looks like all of this is just going to simplify to sine squared. And I can do that same thing over here. So since there's all multiplication here, I can cross what's off on top and bottom. And it looks like this is just going to clean up to cosine squared. Oh, an identity right there. Sine squared plus cosine squared equals 1. So this whole thing just simplified up to 1. Okay, I think I made it to the last one on this day. All right, so this last one for the day was tangent times cotangent minus cosine squared. And again, I don't have any GCFs I can take out. There's nothing that really is sticking out to me for the Pythagorean identities. So I think I'm going to have to change things into sines and cosines for this one as well. So another way to write tangent is as sine over cosine. So let's go ahead and change that. And same thing, cotangent in terms of sines and cosines is cosine over sine. And again, if we think of the order of operations, I always want to do multiplication first. So if I look at this piece, let's see, I have a cosine on top and bottom, so those can cancel. And I also have sines on top and bottom as well. So all of this, everything crossed off, except technically there's ones out in front of all these. Everything crossed off, so we are just left with a 1 here. And I'm going to carry that minus cosine squared down. Ooh, and look at that. I know that's an identity. My side note here, I know sine squared plus cosine squared is 1. So if I want to manipulate this so that it is 1 minus cosine squared, I would have to subtract cosine squared from both sides. And that looks like 1 minus cosine squared can simplify to sine squared. All right, here is day 2's worked out problems. Again, these are by no means the correct answers. There's lots of ways you could do this. So just because you did a different way does not mean it is wrong. All right. Excuse me, there's day 2.